Before we talk about weather, it's important to understand the effects of sunshine on the surface of the planet. So the area around the equator, that is the hottest area because of the lower altitudes and the closer distance to the sun. So it's cooler in the northern and the southern regions close to the equator. And this is very simple temperature pattern on the surface of the planet. But it is important for us to understand, because if you look at this flashlight, so an equal amount of energy radiating from this device, and the area receiving the energy are different, and the distance from the energy source is different. That determines the surface temperature difference on the planet of Earth. And that's one, is understand the sunlight. The second one is the water vapor. So we all know when we are sweating in a dry, cool day, but let's say a dry day, okay? So the water on our skin are more easily evaporated. That brings away the heat from our body. When it is more humid, of course, we feel like hotter. Even the temperature is the same, we feel hotter in the more humid region. So the water content in the air is important for the weather also. And this is the first time I mentioned this, and I'm going to mention this again in the future chapter of climate change. Weather is a short-term change in conditions, right? We talk about daily forecast. We have to check every day. And for the climate, that's a long-term average of the weather patterns. We're talking about different weeks, different months, different years, or even different decades. So what's the trend of the recent weather? Because we all know that California is on fire now. And we can start talking about the facts related to that. This sequoia, I know it's kind of small, Sequoia National Forest is in California here. This is the region it is at. And the scientists found that those trees in this region, a lot of them are died in recent years. And the interesting fact is the trees do not die of the dryness. It died of the infection of the parasites, attacks of the insects. So when those trees are dehydrated, they are more prone to diseases. It's just like our human body, right? When we are dehydrated, there's a bunch of complications of health problem will manifest in our body. The same with the trees. So after these trees are died, you know, the evaporation of the area will be much worse than before. And without the trees transpiring the water and holding the water to the soil, this region will be even drier. And this is a cumulative effects. This is not just caused by one day or 1 week or even by 1 year. This is the result of the climate change accumulated in quite a period of time. Now, some basics about high pressure and the low pressure system. And you can see the dots as the gas molecules. The high pressure system is this cool, dense, cold air. Because they're heavy, they sinks. And the low pressure system is this warm rising air, right? It's expanding. So the density is much less than the cold air. And this is all I need you to know. So when you think about high pressure, you think about cold, dry, dense air. And when I mention low pressure system, you're thinking about warm, rising, humid air. And I want to point out the air masses we're talking about in those pressure systems. They are huge. We're not talking about Houston area or even Texas area. We're talking about the air mass with a large volumes of several kilometers thick and 1,000 or more kilometers wide. So they could be across the country, okay, or across quite several states. So those air masses are huge. That's why we're under the influence of those pressure systems. And I want to mention about the California weather again. And I want to call your attention about this interesting term called ridiculously resilient ridge of high pressure. And this high pressure system was sitting here blocking the rain from the North Pacific to California. And that's the other reason we say climate change causes the dryness of the region. Okay, it's not natural. And we call it ridiculous because it's sitting there for a long time, for several years. That's called the continuous drying up of the region. And I'm not going to test these. These just to show you the different patterns of the movement of the air masses. And I want to the convective means vertical manner. Okay, so when the warm air rises, the cold air kind of sink down, and so the movement is more vertical, and the frontal is more horizontal. So when the cool air moves horizontally, the warm air will rise above and we'll have a rain. It is very interesting. I used to live in Syracuse, and I was a person can testify the lake effects. And Syracuse is a city of snow each year in winter. Because of the lake effects, we have a tremendous amount of snow. It's because of the warmer water evaporate and go up and encounter the cold air in winter. So there's humongous amount of snow dumping in the region. Our graphic, that is a high mountain area. When the warm air have nowhere to go but climbing up the mountain, it will become rain precipitation because it will counter the colder air in the higher altitude. And the last one, the convergence, this is a hurricane system. Okay, so the warm air very rapidly feeding this system, and it's spinning and precipitation occurs. Now the climate, the weather and the climate. So what causes the weather? That's a basic movement. When the cold air sinks down and the warm air rise up, it causes circulation of the air movement on the surface of Earth. And it also caused by the spinning of the planet. That's called Coriolis effect. We just talked about this in the water chapter. So when Earth is spinning like this, the trade winds will bend this way. So that determine on the global scale, okay, in the warm area, the air will move like this. And in the semi-dry regions, the air is sinking and causing the cool and the dry weather, both in northern area and in the southern area, about the 30-degree north and the 30-degree south. So this probably look a little bit busy, but there's only one thing I want to point out. It's the equator. Now let's review that equatorial low pressure belt again. Okay, because this contribute to this constant warm and humid climate. I would say climate in the rainforests all year around. Again, the warm air will rise up. Okay, it will migrate to the higher and the lower latitudes of the planet, and we call these two cells Hadley cells. And they are minus 30 and plus 30 north and the south. And these two Farrier cells, they contribute to the semi-dry and the cool weather of this region. And Hadley cells, they contribute to this warm and humid weather here. That's all I need you to know. So globally, it looks like this. That's why we have different weather in different regions, and we have different climate patterns in different regions. And we call this prevailing wind patterns jet streams, and it's on the top of the troposphere. So we know this is a very powerful winds. It goes like this on the top of the troposphere. I mentioned about the jet stream because those winds are very powerful in carrying the air pollutants all across the planet.